That concludes the introduction to Docker. Hopefully this course has gotten you acquainted with the tools in the Docker ecosystem. Whether you just want a clean way to manage your development environment, or you want a common packaging unit that allows for easiest continuous delivery, Docker can serve as a great keystone for your solution. In this course, we've covered the basics of setting up Docker, containers, images, networking, volumes, Docker Compose, and Docker Swarm. This course just scratched the surface of what you can do with Docker. If you move to delivering production software with Docker, you'll find there's a lot of challenges still to be solved. Running a Docker container in production is quite easy. Running a Docker container in production in a resilient manner is another thing. Modern cloud-like environments where containers thrive afford us a lot of benefits such as elasticity and disposability. Docker is built for these types of environments, but it cannot exist alone. Running containers using Docker Swarm in production allows us to distribute our workloads across a cluster of machines. We can use restart policies to ensure that our containers restart in the event of a failure. But what happens if the whole Docker node goes down or needs to be moved? In its current state, the desired number of instances of a specific service or task is not stored, and so it's up to an external client to monitor and maintain capacity. Fortunately, there are a number of resource schedulers out there that support Docker out of the box. Apache Mesos and Marathon, Kubernetes, and HashiCorp Nomad are great schedulers that can be used for running production container workloads. Monitoring containerized applications in dynamic environments can also present challenges. Fortunately, there are a number of modern technologies that make this easier. Consul, which is also used for service discovery and distributed configuration, is a great tool for monitoring containerized applications that come and go frequently. A number of metrics collection tools are also available, such as InfluxDB, OpenTSDB, and Prometheus, all of which easily handle dynamically changing environments. Docker provides a number of networking options that allow containers to communicate with each other using standards like DNS. But how can containers communicate with other containers in completely separate environments? Also, how can legacy applications interact with containers in a dynamic environment? One way to manage this is to include a service discovery component in your container platform. Service discovery is a way of registering available instances of a service with some sort of central or distributed registry and allowing clients to dynamically look up and load balance calls to the registered service. A number of solutions exist today that work well in containerized environments. Again, Consul is a great scalable service discovery mechanism that is being widely adopted in cloud and clustered environments. Other solutions, like Apache Zookeeper and etcd, are also good battle-tested options. We've learned how to build Docker images and how to run Docker containers, but we need to tie these processes together by another automated process. This is where continuous delivery comes in. For maximum efficiency and speed to market, continuous delivery allows us to push changes into source control, automatically build, test, and publish our artifacts, and then deploy them to a number of environments. Docker helps to make this easy by providing a standard delivery unit. Continuous integration and delivery tools like Jenkins, TeamCity, and Bamboo exist to help orchestrate a delivery pipeline. The biggest concern that unfortunately no one has found a perfect solution for is security. When we're deploying production services that deal with sensitive data or interact with data stores that store sensitive data, we need secure ways to authenticate and authorize communication between these services. Docker relies heavily on environment variables or mounts to configure applications, both of which present security concerns. There are a number of new tools available to help with storing and providing secrets. Tools like HashiCorp Vault, Amazon KMS, and KeyWiz are in active development to make it easier and safer to store and distribute secrets. Basically, there's still quite a bit of work to do if you're building a production-ready container platform. You shouldn't worry though, these technologies are still new and maturing quite fast. In fact, a number of changes in the Docker ecosystem happened over the course of me producing this video course. With each version of Docker, new features are added, while others, such as container links, are deprecated. I suggest you keep your eye on the documentation frequently to find out about new features. Every release of Docker has a number of features that will make your life easier. Also, a number of new products have been announced recently that are worth taking a look at. Docker Universal Control Plane is now available, which allows Docker users to manage Docker workloads on-prem or in private clouds through easy-to-use dashboards. Docker Data Center is also now available, which is the whole package, including Universal Control Plane and Docker Trusted Registry. These solutions provide enterprise-grade features like LDAP access controls. Also, a new Docker for Mac and Windows beta was announced that eliminates the need for VirtualBox to run Docker. A number of other improvements have been made in terms of installation and Docker features. All three of these products are well worth keeping your eye on. And that wraps up the introduction to Docker. Please feel free to email me with any questions or concerns. Thanks for watching.